Hello, everyone. Welcome to Chapter 14, where we're going to discuss synthesizing research and more specifically, the meta-analysis. My name is Jimmy. My partner is Arthur, and he will be joining us shortly. So just to get started, what we're going to talk about today, like I mentioned, we're first going to discuss the research synthesis. Um, we'll discuss a few issues that exist with synthesizing research. We're going to discuss the meta-analysis, which will lead into the effect size. And we'll ultimately present a few examples of meta-analyses. And then lastly, we'll send it over to Arthur, who will discuss a few more methodological considerations with effect size and meta-analyses. So first off, what is a research synthesis? Now, we've all done literature reviews before. So this is really when a literature review is a research paper. It becomes a research paper in and of itself. So, and when does this really happen? When can that happen? It's usually when the goal is to use the literature to draw empirical and theoretical conclusions rather than to document the need for a research problem or further research, for example. And so a research synthesis, more than a literature review, will lead to several tangible and valid conclusions. It will lead to evaluations of hypotheses previously and how to potentially adjust them in the future, things like that. It'll also potentially result in the revision or the proposal of a theory. And theory, I think, gets thrown around a little bit too much, but theory is something that has been backed by very high amounts, vast amounts of credible scientific literature. And so that's ultimately what the goal of a research synthesis is. And then lastly, it's meant to spark interest and future directions of research, not just future research projects on the same problem, but actual future directions and avenues of research. So it's really meant to expand the understanding of a certain topic. So it's really much more than just a summary of related literature. Okay, but there are a few issues with research syntheses. They don't always answer some pertinent questions, such as what kind of search criteria was included and what were the processes associated with actually accumulating all those research articles. Was it thorough enough? Was a computer search used as well as a hand search and one or the other? What databases were used? What descriptors were used? Things like that. Also, what inclusion and exclusion criteria when you did find the articles? What caused you to throw some out or include some in the study? Were theses or dissertations used? How was internal validity, sample size, things like that? How did those play a factor in those criteria? And then also, how did the author arrive at certain conclusions? Studies aren't all equal across the board, so certain studies will be weighted differently. And what factors played into that? Was it just simple vote counting, where you took the number of studies that said yes versus no, for example, and used that as the basis of conclusions? It leaves a lot of questions unanswered. And so ultimately, that prohibits an objective evaluation of the decisions that led to the conclusions made by the authors. And as we all know, good research involves a systematic method of problem solving. So if we can't adequately follow the same path and figure out how you came to your conclusions, then it's not necessarily useful science. So the result is a meta-analysis, which is going to take it a step beyond just a research synthesis per se. And so what is a meta-analysis? It is a technique of literature review that contains a definitive methodology and quantifies the results of various studies to a standard metric that allows the use of statistical techniques as a means of analysis. So there we're getting into a literature review becoming a research project in and of itself. And this was proposed originally back in 1976. But since then, it's gained a lot of weight, especially in the health and medical fields. About a decade later, after the meta-analysis was created, there was concerted efforts to incorporate them more into our understanding of certain topics. And ultimately, if you are going to conduct a meta-analysis, a great book was written called the Handbook of Research Synthesis in 1994, which details basically all the potential possibilities of a meta-analysis and the process in which you would go through to conduct one. All right, and then in the field today, there are several art journals out there that are dedicated to strictly review papers, especially in the medical exercise science field, where there's a large compilation of primary literature. Um, so there are a lot of journals that are dedicated solely to analyzing and presenting review papers. And so we're getting into the purpose of a meta-analysis. This is really the steps you would take to conduct a meta-analysis. First, we need to identify the problem. With a meta-analysis, that should be somewhat simple. There should already be a agreed upon issue that a lot of papers have already approached. Second, you need to perform a literature search, which is what we always do, but it has to be by specified methods. We need to review and identify studies to determine their inclusion or exclusion properties, and we need to present those as well. So it's important we are very clear on that. Also, step 4 is to read and evaluate those articles to identify and code important characteristics, similar variables, and things like that, that we can ultimately compare between different projects. And then number 5 is to calculate the effect size. And so we're going to get into effect size right after this. But that's something that's different than most primary research or a survey or observational study, anything like that. And then number 6 is that we need to apply appropriate statistical techniques as well. So that's taking it a step further than a normal research synthesis. And then the last step is to report all of the steps and outcomes into a review paper. Very important to report all of those steps. So the question really looms is, how do we compare different studies? Not always the same. You'll find differences in subjects, the samples, how they were taken, the design of the study, the variables used, and the different statistical analyses that are run. The way that we're going to do that is through effect size. And effect size has a wide range of uses beyond just meta-analyses. Even just a correlation is an example of an effect size. You might have heard of Cohen's D, the difference in effect sizes. So you'll see it often, but it's very important for meta-analyses. And it really just provides a way of judging meaningfulness of group differences, especially when the groups might be a little different in and of themselves. And so to get into effect size, this is the equation for it right here, which will be denoted with ES. And ultimately, it's very simple, but it just takes the experimental group mean and the control group mean. We find the difference between the two and divide it by the standard deviation of the control group. And so as an example, if we throw out some figures used in your book, actually, if we have the value of 15 as the experimental mean, 12 for the control group, and a standard deviation of 5, if we throw those into the equation, we'll end up with an effect size of 0.60. But that doesn't really mean much in and of itself. So how do we interpret that? And so this figure here just kind of denotes what we're doing here. So the difference between 15 and 12 is 3, which is basically what D is assessing the difference here. So it's just showing you how basically far apart the two groups are. And so how do we interpret effect size with our same example here? Basically putting it into words, we're saying that the experimental group's performance exceeded the control group's performance by 0.60 standard deviations. It's basically just the amount of difference that was observed. And so we're going to do this for a study, each individual study, and ultimately across multiple studies, what the result is that you put them all into a standard metric so that now we can compare them. In this case, it would be ES. In other cases, it could be R or uh, a lot of other options. To take it one step further, even though we're pretty simple here, just to take it one step further, if you wanted to distinguish between two different groups, such as males or females, elite recreational, athletes, etc., you're actually going to calculate an effect size for each group within a study. Um, and then you're going to compare those two groups amongst other studies. And ultimately, you would probably run a t-test of some kind to compare those two. Um, it gets a little bit more hairy, and so we're actually going to go to Arthur, who's going to discuss a few more ways, a few more methodological considerations for that we must take into account when calculating effect size. Before we do that, I just wanted to show you one more example of a meta-analysis on a topic that I'm kind of interested in. The title I'll read for you is an evidence-based approach for choosing post-exercise recovery techniques to reduce markers of muscle damage, soreness, fatigue, and inflammation. A systematic review with meta-analysis. It's pretty clear that it's a review and it's a meta-analysis. They could have probably whittled down that title if they listened to Ryan's lecture earlier in the semester, but I think it was Ryan. But I wanted to show you a couple of examples of figures that were pulled from this article. This first one is all about how they whittled down the number of articles that they included into their study. So they talk about with how they identified them, which databases, how they were screened, which ones were eligible for the study, and lastly, which ones were included. They give you the numbers, and then there's also written descriptions getting more in detail on how that process went down. So very important for a meta-analysis to be clear on how you came to the pool of articles you're using. And figures help a lot with that. I want to show you this table too, because there's a column here, which is the standardized mean differences. So we're able to compare kind of a standard metric across a lot of different modalities and articles and subjects and all that stuff in one concise table. So that's one of the benefits of a meta-analysis. And then lastly, I wanted to show you this graph. I know you can't really see it, but this is a funnel plot, which is very common for meta-analyses to include. And it basically just shows the distribution of the articles. Each data point would be an article, I believe, and based on a certain metric, which we obviously can't read, and it's unimportant for us right now. And just if you were interested in this article and what these authors found, they did find that several of these different modalities did decrease the magnitude of DOMS, but massage was by far the most powerful. And second was probably the cryotherapy. So just in case you're interested in that. But with that, so we'll send it on over to Arthur, who's going to talk a little bit more in detail about some methodological considerations that you need to take when conducting a meta-analysis. All right. Thank you guys very much and enjoy. It's all you, Arthur.